asking for a minute. So here we go. Hi there, everyone. Thank you so much for joining us on day 2 of the Explore ML session. So I am your host for the day. This is Ankita. We also have the organizer Pravesh here, as well as your amazing Explore ML facilitator Abel here, who's going to take another great, interesting, and interactive session today. So I would really like to call him aboard, and we should start the session. Abel, the floor is all yours.
Hello, hi, folks. I'll quickly start my screen share, which should come up in the next few seconds. Once you folks can see my screen, which I suppose you can see, we should be good to start. Yeah. Hello all. Welcome to the part 2 of the Explore ML beginners track. I suppose all of you are folks who had attended day 1, which was 2 days ago, on Monday. If any of you who is here is someone who has not attended, feel free to continue staying because you can still understand what is happening. Is there anyone who is joining this and not attended the first one? In case, I would recommend you to fill the form, or else we are good to go. Anyone? I recognize almost all the people. I assume the silence that everyone had attended a previous session. I'll wait for a few seconds more and then we'll continue. In case there is someone who had not filled the form, for the sake of informing you, this is the form that you're supposed to fill. And well, yeah. Hello, hi, I'm Abel Mathew. Let's begin the session. This is the form in case you are wondering, the form which is bit.ly by 3JG0HZR, except our everything is in capital letters. So, yo, we can begin. Ta-da-da. If you have read anything about machine learning, you may have come across this term neural network. They are popular choice for machine learning models because of their ability to handle complex data and make accurate predictions where simple models might fall short. When we say simple models, they are things like regression models or basic models like we have in stats. It could be linear regression, it could be logarithmic regression, or anything along those lines, the basic models. Let's start off with a video with few Google engineers. So yeah, the audio should ideally be coming, which we'll know in the next few seconds.
Hi, I'm Nat.
And I'm Lo.
And this is our 20% project, where we go find out about different Google stuff we're curious about.
Last year, we got to make a documentary about how voice search works. And that was the first time we heard about something called machine learning.
Since then, we've been kind of fascinated by it.
So today we're talking with Greg and Chris to learn more about it. How would you describe machine learning to someone?
Well, there's a lot of problems that's really easy to solve with computers. Computers can go and simulate how galaxies move and how the courses of asteroids going and how close they're going to come to Earth. I could never hope to go and do that, but I can go and do this problem like recognizing that that's a tree, which is so much tremendously more difficult for a computer.
It doesn't feel like intelligence to us because it's so effortless as a human being to do it. But for a computer, it's actually really hard.
Because the real world is kind of messy and unpredictable at times. The strict logical rules that go into traditional programming just don't work.
Instead of going and writing programs that solve the problem, we write programs that learn to solve the problem from examples.
And it's this process of learning that allows them to improve over time and to actually be more clever than they would be if we wrote down a very rigid set of instructions for them to follow.
Machine learning is in so many different things that we use today that it's kind of like this invisible magic ingredient.
Phones with the ability to understand human speech.
Machine translation, email spam filters.
When you go to the ATM and you give a check and it can read the handwriting.
Or a Photos app that can automatically organize your photos based on the things that you like to take photos of. Like, here are all my mountain photos, here are all my food photos.
Here are all my dog photos.
Here are all my feet photos.
Everything from facial recognition to going and trying to recognize whether a particle is present in a particular collision at the LHC.
Which we just like to take a time out to say is that big tube in the ground over in Europe that smashes particles together at really fast speeds so that scientists can use that information to unlock the mysteries of the universe, among other cool things. Now back to our episode, because I am getting really dizzy doing this. Ooh, ooh.
So researchers and scientists are still experimenting and trying to find the best ways to teach computers how to learn. But a lot of the progress is coming from these algorithms that are based roughly on how the human brain works, and these are called artificial neural networks.
So an artificial neural network is something that it's a rough mathematical cartoon of how a biological neural network works. In a biological brain, we have individual cells called neurons. Each neuron looks at what its neighbors has to say and then decide what it wants to say. And in artificial neural networks, we have little mathematical functions. We put them in some organized structure, and then we say, okay, you guys all together, learn to do this task.
We have lots of neural nets that are really great at going and recognizing, this is a cat, this is a dog, this is a frog, this is a mouse, this is a horse, this is a truck, and things like that.
So take, for example, trying to recognize what this is.
So it used to be that we were really proud if we could get a neural net with 3 layers to work. And it's recently that we've made a lot of progress on techniques that allow us to train much deeper neural nets.
And that's why this kind of machine learning is also called deep learning. A neuron in the bottom layer is just going to be looking at a tiny piece of the picture and making some computations about it. It doesn't understand anything about dogs specifically.
But what the neuron does understand is it says, I'm giving a signal that's useful for somebody who's giving a signal, who's giving a signal, who's giving a signal, who's giving a signal.
They're kind of able to unfurl this really high-dimensional knot and pull it apart and make it easier to go and separate different things that are close together on the surface from things that were tangled all together earlier.
But then at the top, we'll put 2 neurons, and these neurons look at the whole picture so far.
They're basically experts at making the final call, figuring out, oh, all the layers below me said these things, so I know that this is a dog, or at least I'm 92.4% sure that it's a dog, so it's basically a dog.
And while there's been a whole lot of progress with teaching computers to learn, they're still much slower learners than we are, and they make mistakes that you and I wouldn't.
So what I was working on is sort of trying to find a way to go and look at a neural net and ask, what does the neural net think the platonic ideal of a cat is, or the platonic ideal of a dog, or anything it can classify as? And suddenly you can go and ask, neural net, what do you think a cat looks like? And you get a picture of a cat. Or, neural net, what do you think a barbell looks like? So these weights. And it goes and it shows you a picture not only of a barbell, but of an arm attached to a barbell. So the model thought that the arms, it only learned what barbells were from looking at pictures of barbells, and they're often held by muscular weightlifters. And so it learned that there was, barbells have arms attached to them.
It takes them a long time to learn. You show it a picture of a school bus when it's early in learning. The very next time you show it a picture of a school bus, it's only a little bit more likely to say school bus. It doesn't get it, even though that was the very last thing it saw. Whereas, say to a kid, that's a filing cabinet. And then a second later you say, what's that? Yeah. He's not going to be like, shoe, right?
Well, the more you describe this, the more I'm amazed by human beings.
Yeah.
The effect is wow, human beings are really amazing.
We're really amazing learning machines.
I suppose you folks got a brief overview of what neural networks are. So the main takeaways are that some problems that are super easy for us human beings are super complex for computer science, like recognizing a tree, as said in the example, and some that are super complex for us, like calculating planetary motion and stuff like that, are super easy for computers, because wherever there is strict formula, strict algorithms, computers are super fast, super efficient at doing it. And wherever there is no strict formula, no strict algorithm, that's where computers lag it, because computers are good at doing what they are told to do, and learning is a difficult task. And that's where machine learning comes in, and it takes a lot amount of time, lot amount of efforts to curate the network, to have the right examples, and then to train and to test it. What is a neural network? In short, it is a mathematical function that maps a given input to a desired output. So neural networks at the heart of it are mathematical functions. It's based on linear algebra. The picture that you see right now over here, the animation This is not how the computer calculates it, but this is a good example for us to understand how it works underneath the hood. In the introductory module, you learned about a couple of types of machine learning models, such as classification, regression. Simple models work fine with simple data, but as soon as you want to interpret complex data like image, audio, or even numerical data with lots of variables like the housing problem that we saw, which has parameters like location, number of bedrooms, size, a lot of parameters. We need something capable of dealing with that complexity. These simpler models are connected into layers, and this is where the depth of the term deep learning comes from. In reality, a neural network is a big complex mathematical function, which looks nothing like what you see in this diagram. Like any other machine learning system, a model is trained with data fed into the model and it attempts to make a prediction. At first, the prediction will be essentially garbage, but the feedback is used to improve the model. Once the prediction quality is sufficient, the model is tested with new data and it makes a prediction based on what it learned from the training data. What this diagram doesn't show is how each neuron is able to learn and improve based on feedback, which we'll cover in the upcoming few sessions. So essentially what happens is that when we start off, all these weights are equally distributed and the outcome will be a random number, something which is equally distributed among the output. Okay. Given that it is a training data set, so given it, give it a picture of a cat and all these values come out equal. So, and we'll also have a corresponding ideal output. So the difference between the ideal output and the output that the output layer gave is known as the cost function. And essentially what we want is the cost function to reduce because we want the output to be as close to the ideal output. And based on that difference, we then adjust these values and we do it over and over again until we are able to have the output really close to the expected ideal output. And once we reach there, then we move forward and test it. Does that make sense?
One doubt. That function you told, like, which should reduce?
Yes.
Like, how do we find like that function?
Okay, so when you train the model with the training data set, you know what the output is. So you're feeding it an image of cat. You know it is supposed to be a cat. Okay. So you know the ideal output that you're supposed to get. So that is one parameter. And the other parameter is the output from the function. You got two parameters. The difference between two is what the cost function is. You already तुम्हें पता है कि output क्या देना चाहिए. तो जो होना चाहिए जो मिला है उसका difference is the cost function. Make sense?
फंक्शन कैसे मतलब एक एग्जांपल
ओके सो मान लेते हैं कि आउटपुट में बस दो ही नंबर्स है ठीक है 1 and 0 1 ओके one second let me just quickly this is a very ओवर सिंपलिस्टिक एग्जांपल डू नॉट टेक इट टू हार्ट ठीक है तो मान लेते हैं कि हमारा एरे आउटपुट आता है मान लेते हैं कि ये फर्स्ट वाला परसेंटेज है कैट का और सेकंड वाला परसेंटेज है डॉग का ठीक है तो मान लेते हैं कि हमारा न्यूरल नेटवर्क का आउटपुट दिया we are starting off from base so let us say कि give the output to 0.5 पूरा random ठीक है and हमें पता है कि ideally the input image is supposed to be a cat so for the input image cat we know that the output we expect is 1,0 make sense with me till now
हाँ
ठीक है so what we will do is that we will do 1 minus 0.0.5 we take a square of it so that we always get a positive value तो इसका यहाँ पे हम लोग स्क्वायर करते हैं then यहाँ पे we do plus 0 minus 0.5 यहाँ पे इसका स्क्वायर करेंगे तो ये हो जाएगा कॉस्ट फंक्शन ठीक है overall idea is to reduce this value ठीक है by modifying the parameter so that we get a reduction in this cost function make sense
हाँ got
cool
और एक वो जो क्या डिस्ट्रीब्यूटेड बोले लाइक पहले सारे नोड्स या पहले सारे नोड्स इक्वली डिस्ट्रीब्यूटेड थे
initially we do not know what these weight parameters are going to be okay so we put there are two ways to start off there are multiple ways to actually start off okay so as an example if let's say if we're trying to solve a model which is trying to solve a physics problem someone who is good at physics may be able to make good initial guesses of the weights ठीक है if someone is not experienced what we'll do is we will put equal weights to all the weights हम सब में यहाँ पे सारे के सारे weights को 1 1 1 1 डाल देंगे and then we'll see what the output comes as so it will be some garbage if you have if someone is
वही
trying it
वही
out,
वो weights, वो
yes.
weight वाला part थोड़ा मतलब कैसे हम define करते हैं weight क्या होता है?
Weight initially we will give them as one. We will cover the basis of weights in the next upcoming session. But initially हम जब start off कर रहे हैं, if we have got no prior knowledge ki what it is supposed to be, we give them all either random weights using a randomizer, or we'll give them all of them one. And then we'll rely on the cost function to let us know कि कौन सा weights काम कर रहे हैं, and then accordingly adjust the parameters.
Oh, okay, thanks.
Sure. So if I were to proceed. Yes. Okay, there are multiple okay, we'll cover the concept of activation function. Activation function is a function. It's a mathematical function, and each neural network you can assume is composed of an activation function. Okay. So we have an input coming to the activation function, and we have an input coming to the neural network. We have an input coming to the neural network, and the activation function is a function which determines whether or not the neural networks, that particular neuron is going to get activated or not. This is very much inspired by the biological neuron that we have, which either gets activated if the signal is corresponding to its activation, or it does not get activated. So this is very much related and inspired from the biological neural and the human brain that we have. So some example of activation functions are a sigmoid function, which is 1 by e plus 1 plus e power minus x. So when we have this activation function, so these numbers, the output of this function is the output of that particular neuron. And then we'll also define a threshold, and beyond which we'll assume that yes, the neuron is activated. So we can say कि if we are using this activation function, and let us say that we say that 2 से ज़्यादा होगा तो activation होगा. So if output of this function is more than 2, then we'll consider the neuron as activated. So this rectified linear unit function is one of the very commonly used linear activation functions, which is used in one of the, if we are starting it off and we don't know what activation function to choose, a lot of people would end up using Telu because it's easier to compute, because the one you see on the top is difficult to compute, it involves more computational power, and this is a very simple function, and this works really well. So it is efficient and fast. You could be other activation functions like tan-h or anything along those lines. So activation function, essentially you can consider like an if-else logic. So we have an input. The activation function is the if-else logic. If it passes the if-else condition, it will activate the neuron. If it does not activate the neuron. This is how our biological activation neuron works, and this is the inspiration for artificial neurons as well. This operation is carried out for all the neurons that you have in the network. So there is a so this calculation happens for each of the neurons. So if you go back to this example, यहाँ पे वो animation आ क्यों नहीं रहा? मैंने कुछ delete दबा दिया क्या? Okay, something has happened. The image is not coming. Weird. Which we can see later. हाँ. If the activation function is a very simple function saying that input should be less than 5, so input should be less than 10, and the input is 5, then it will activate the neuron. Or else if we have something like this, whether it has a curve or not, then 7 does not have a curve, it has an edge, whereas 6 has a curve, whereas in this definition curve is assumed if there is at least 2 edges, and it will activate the neuron. So based on your definition of the neuron, the activation function will or will not get triggered. Anyone, any doubts? So in this example, this is an example of how a neural network with multiple hidden layers works. So this is also for just representation purposes. So the width of the line that you see essentially corresponds to how big of an output is coming from this. Okay? So if you take an example of this particular line, यहाँ से यहाँ, which means कि यहाँ से यहाँ का जो corresponding connection है, or in terms of mathematics, the weight connecting this node to this node is giving an output which is really low, so close to 0. So initially when you start off, all of this will be having equal level. So all of this will have equal intensity. And then as time progresses, depending on which nodes correspond maximum to the output, then the width of this neural network, which corresponds to the value given as output from this neuron increases. So essentially इसका ये मतलब है कि the connection between this neuron and this neuron is strong for the case when the Labrador retriever is the input.
So these images that is shown in the rows, those are the predefined images, or were those computed by the machine learning neural network?
Yeah, that's a very tricky and that's an area of research. So जैसे कि हम बोलते हैं कि when we take a look at dog, हम देख रहे हैं. So what exactly is the neural network saying? It is possible. So we may have our own theories. There is no strict hypothesis on what exactly the neural network is saying, but one of the ways to analyze is that yes, the first layer is taking a look at the pixel, the second layer is trying to pick up the features, and third layer like that. But there is no strict hypothesis to verify that until and unless you backfill the parameters and actually check it out. So it's possible that in your case, it is doing something else. It's not necessarily doing the same. A neural network can be comprised of many hidden layers. These are intermediate steps to get from prediction to the output. For example, a neural network may have layers to detect certain colors, shapes, and other layers to differentiate between certain types of animals and breeds. We'll go through an example which will give us more clarity. It is important to clarify that the neural network does not know what a dog or a cat is. It is just learning to do what we want it to do based on the feedbacks and the pattern it detects.
So it's basically like it is identifying different characteristics in this image and how much each characteristic match. It's like that.
Yes, but we are saying it as an image. But from the computer's perspective, all of it is mathematical function. So we have got so an image and everything. So each pixel is a mathematical function which takes input from 0 to 255. If it's a black and white image. So 0 is black, 255 is pure white. The moment you go to colors, you have got power 3, three times that. Yeah. So the same way that for us, those pixel values mean images. For the computer, those pixel values just mean some mathematical functions. So that's the difference.
Yeah, got it.
So the smart camera and the image label verification task on the Google Crowdsource app is one of the great examples of neural networks, as I have told earlier as well. So I would recommend to contribute to the Crowdsource app because it helps us to improve the machine learning systems that we have across. So as said, the primary part of this session today is to experiment with stuffs. I don't want to show it in slides. I want to cover it in terms of example. So let me quickly open this link, which I always mess up. This is the link. The link is playground.tensorflow.org. So we will experiment with it and we'll learn something. Okay? Once you folks have opened this, I'll start. We'll wait for 30 seconds. Shall I begin? Yeah. तो मैंने इसको खोला है, मैंने सारा रीसेट बटन दबाया है just to make sure कि मेरा कुछ पुराना स्टोरेज इसमें नहीं हो, but हाँ, I'll just quickly reopen it. So this is how we start. ठीक है, nothing is saved. ठीक है. So explaining. So this is a playground created by the TensorFlow team to experiment with neural networks. Hello. हम begin करते हैं. Yes, बोलो.
One question is that a neural network is important for machine learning. And yes.
बोलो आगे बोलो.
बस इतने question.
So the reason why neural networks are used extremely machine learning is because इनका maths a simple है and इससे almost बहुत सारे problem solve हो जाते हैं. ठीक है. Are neural networks the only way to solve? No, but at the moment they are one of the most used one because it helps us to create as many deep layers as we want and go ahead with things. But yes, it is one of the old ones, and we also have as I said, the learning that happens. Okay, so the feedback and the cost function. So even today's modern machine learning methods like the LSTM1 or anything else, the learning that happens from the cost function to adjusting the weights, वो adjust कितना जल्दी कर सकते हैं, उस पे ज़्यादा research होता है, so that we can have less amount of time spent in training, so that we start off with random numbers, and how do we adjust the weight so that to quickly reach the optimal solution? So there are multiple ways in which we can reach that. So essentially, in terms of calculus, in terms of mathematics, so you can assume all of this to be a mathematical function, and essentially हम ये चाहते हैं कि the cost function को minimize करना है, which essentially means that we are finding a minimum of the function. So in terms of calculus, it is like we are taking the derivative and finding where the slope is 0. So that's what is happening. So we are trying to optimize the route to find the minimum, if that makes sense. Okay. So minimizing the cost function is finding the minimum of the function. ये समझ गया ना? That's a little bit technical, but given that we are all from engineering college, I think this makes sense.
Yes, this was already being taught to us.
So linear algebra लोगे, then we have got, so if you take in terms of linear vector algebra, it is essentially finding the gradient and then going down the route of maximum gradient to reduce the function. Essentially वही हो रहा है. ठीक है? But हाँ, तो हम खेलते हैं इसके साथ. So what we are trying to do over here is that we want the machine learning model to be able to draw a boundary between the blue dots and the orange dots. That's the goal that we have over here. And we want to do it with the minimum number of neurons. The reason why we want to do it with the minimum number of neurons is because it is efficient and we do not want to reduce waste computational power. The goal is to do that. So यहाँ पे ये एक न्यूरॉन है, इसका फंक्शन है x1, इसमें x1 x2 है वेरिएबल्स. तो ये x1 है, ये x2 है, इसमें x1 स्क्वायर है, इसमें x2 स्क्वायर है, ये x1 x2 है, ये साइन है और ये sin x2 है, sin x1 sin x2 है. ठीक है. So these are the mathematical functions for these neurons. ये सब न्यूरॉन्स, अंदर के न्यूरॉन्स के एक्टिवेशन फंक्शन यहाँ पे चूज कर सकते हैं हम. तो रेलू है, सिग्मॉइड है, लीनियर है. One of the reasons why sigmoid does not work in many cases is because sigmoid का अगर तुमने देखा होगा, so उसका output between 0 and 1 है. So the amplification of the output is low, so it takes time for it to learn. Whereas रेलू में output का amplification पे limit नहीं है, so it can activate more. So that is why तुम अगर sigmoid के साथ ट्रेन करोगे तो हो सकता है कुछ केस में ट्रेन होने में बहुत टाइम लगता है. So you start off with the रेलू one. ठीक है. Regularization rate we will discuss after some time. ठीक है. Ratio of training data to test data. This essentially means that हमारे पास अगर 1000 examples है तो उसमें से कितना परसेंटेज हम ट्रेनिंग में यूज करें, कितना टेस्ट में यूज कर रहे हैं. क्योंकि हम ट्रेनिंग के टाइम पे हम बस एक सेट ऑफ डेटा यूज करेंगे एंड टेस्ट के लिए हम न्यू डेटा यूज करेंगे बिकॉज वी वांट टेस्ट टू हैपन ऑन न्यू डेटा सेट. होता क्या है कि अगर तुम पूरा 100% लगा दोगे ट्रेनिंग पे एंड टेस्ट नहीं करोगे, so there is no way to actually know कि whether the neural network actually learned something or it just in terms of few machine learning engineers just memorized it. So to make sure that it is not working just for your example but for all scenarios, we divide the data into test and training. Noise essentially is noise. So जैसे कि यहाँ पे देखो कि ये पूरा clean data है, नॉइस डालेंगे तो तुम देखोगे कि यहाँ पे बीच में थोड़ा ऑरेंज आ गया है. एसेंशियली गोल ये है कि ये नॉइस है, सो वी विल इग्नोर द नॉइस. गोल ये है, वी डोंट नॉट, बिकॉज इफ यू डू नॉट इग्नोर द नॉइस, यहाँ पे हमारा आउटपुट एक्सपेक्टेड सर्कल है. इफ यू डू नॉट इग्नोर द नॉइस, हम यहाँ पे पूरा अंदर से पूरा एकदम स्ट्रिक्ट बना देंगे लाइन. सो देन जब नॉइस कहीं और होगा तो मॉडल काम नहीं कर पाएगा. मेक सेंस? व्हिच इज व्हाई it's important for the machine learning model to be able to understand what is noise and what is not noise. अभी तक कॉन्सेप्ट समझ में आया कैसे काम कर रहा है चीजें?
Yes, so by adding noise हम ये चेक कर रहे हैं कि ये वाला मॉडल कैसे काम कर रहा है. whenever there is a noise in a picture or an image, how does this model respond in that case? That's what we're checking, right?
yes. जैसे कि वो वाला एग्जांपल जो वीडियो उसमें देखा था, स्टॉप साइन देन स्टॉप के ऊपर स्नो लग गया था, फिर भी रिकॉग्नाइज कर पाया था. So being able to handle noise is important for neural network to be able to be more scalable. ठीक है. तो हम अभी बस noise zero के साथ
here it is trying to like draw a circle or a boundary and whether it's able to detect it or not, right?
essentially सुनो, यहाँ पे हम बाउंड्री ड्रॉ करना चाह रहे हैं. विथ नॉइज द एक्सपेक्टेड बिहेवियर इज दैट सर्कल आएगा, क्योंकि हम नहीं चाहते कि यहाँ पे कुछ अजीब सा कर्व आ जाए, क्योंकि अजीब सा कर्व हो सकता है इस एग्जांपल के लिए काम कर जाए, नॉइज कहीं और होगा तो काम नहीं करेगा. अगर सर्कल होगा तो नो मैटर व्हाट यू सी, इवन इफ आई लाइक रैंडमाइज द डेटा, हमारे डेटा हमेशा आउटपुट सर्कल ही आ रहा है. ठीक है. तो हम चाहते हैं कि ये सर्कल है करके समझ पाए. समझे?
Yes.
ठीक है. सो ओके, सो ये एक प्ले क्लिक करने से स्टार्ट होता है. ठीक है. सो अभी के लिए हम स्टार्ट करते हैं 2 न्यूरल नेटवर्क। ओके, चाहे तो एक क्लिक कर सकते हैं, इसको हम ये भी मैनेज कर सकते हैं। ठीक है, सो वी आर जस्ट सबसे मिनिमम पे है। इफ यू क्लिक प्ले, लेट अस सी व्हाट हैपेंस। ठीक है, सो द reason why it is not able to find any output, so you can say ये stabilize हो गया। ठीक है, ये stabilize हो गया, ये अब और घटेगा नहीं। I'll just count loss. So 0.5 is the value, which means 0.49 0.4 केसेस में वो डिटेक्ट कर पा रहा है। If I just refresh and try it again, तो हो सकता है 0.5 भी आ जाए। तो essentially a random output इधर है। ठीक है, the reason why it is not working is because the output is supposed to be a non-linear function. A circle is a non-linear function, and हमारा यहाँ पे input इतने इनपुट से कभी भी नॉन लिनियर आउटपुट प्रेडिक्ट नहीं हो सकता। ठीक है, तो इफ यू गो अ लिटिल बिट मोर रियलिस्टिक, अ लार्ज अमाउंट ऑफ एफर्ट्स गोज इनटू अंडरस्टैंडिंग कितने लेयर कहाँ डालना है। वो एक्सपेरिमेंट एंड एक्सपीरियंस से ही आते हैं। एक्सपेरिमेंट एंड एक्सपीरियंस हम उस एक्सपेरिमेंट से आते हैं। सो लेट अस टेक कि हमारा एक लेयर हिडन यहाँ पे है, एक यहाँ पे आउटपुट लेयर है, दोनों में दो है, एंड इसमें कर पाते हैं डिटेक्ट। ठीक है, मेरे हिसाब से इसमें भी नहीं हो पाएगा, बट एज यू कैन सी इतने न्यूरल्स के साथ वो मच बेटर कर लिया है। टू एन एक्सटेंट वो अंडरस्टैंड कर गया है कि यहाँ से यहाँ हो सकता है। तो एसेंशियली इट फील्स लाइक, इफ यू टेक अ लुक एट इट, यू कैन सी दैट इट इज लाइक ये यहाँ पे ये बाउंड्री ड्रॉ कर पा रहे हैं, एक और बाउंड्री मिसिंग है। दैट्स एसेंशियली व्हाट यू कैन सी फ्रॉम दिस। ठीक है,
तो यहाँ पे इसको ब्लू वाले डॉट पे ब्लू वाला एरिया को रखना है और ऑरेंज वाले डॉट पे ऑरेंज वाला एरिया को रखना है, यही इसका टारगेट है ना?
यस यस यस। सो इफ यू सी ये जो है, तो इस पे क्लिक करने पे तुमको वेट भी दिखता है। ठीक है, तो ये ब्लू वाला का देखो वेट दिख रहा है 2.4 और लाइन भी कितना थिक है। एंड इफ आई गो टू दिस, ये थिन वाला है, वेट देखो -0.28 है। सो एज आई सेड, दिस थिकनेस इज एन इंडिकेटर कि इससे आउटपुट कितना आ रहा है। ठीक है, इफ आई जस्ट ऐड वन मोर न्यूरॉन, आइडियली इट शुड बी एबल टू फाइंड द बाउंड्री, व्हिच इट इज एबल टू फाइंड द बाउंड्री। ठीक है, सो इतने न्यूरॉन के साथ वो एबल बाउंड्री फाइंड कर पा रहा है। बट as we folks are, I'll just give it one more shot. So you can see the training loss, test loss is much low. Like it is training पे 0.01 है, which okay, training पे 0 है, मतलब इसका मतलब है कि ट्रेनिंग पे पूरा 100% काम कर रहा है। एंड टेस्ट डेटा पे ये कुछ केसेस पे काम नहीं कर पा रहा है, which is expected because ट्रेनिंग में परफॉर्मेंस बेटर होगा क्योंकि टेस्ट में यू आर गेटिंग न्यू डेटा सेट। मेक सेंस? ऑल गुड until now?
यस।
So अब now that we are a little bit experimented with the mathematics, तो हम एक और मस्त तरीका कर सकते हैं। हमें पता है कि सर्कुलर इक्वेशन x² + x² होता है। So technically speaking इससे काम करना चाहिए। And you can see it works.
Yes.
So this is where the advantage of prior knowledge comes. जो बंदे को पता है कि हाँ इसका इनिशियल गेस इस तरह करना है, he can just quickly come and do it. Initial guess, जैसे कि if it's a model in the terms of let's say machine learning using in physics or somewhere, so a physicist may be able to make good initial guesses, but even
तो
with,
यहाँ पे इक्वेशन का अच्छा वो नीचे x1 x2 ओके ओके गॉट इट।
ठीक है, तो हमें पता है कि सर्कल की इक्वेशन ये है, हमने उसको यूज कर दिया एक्टिवेशन फंक्शन में, एंड हमारे पास झट से काम हो। ठीक है, सो वही है फॉर पीपल हु हैव गॉट अंडरस्टैंडिंग ऑफ हाउ हम क्या सिस्टम को प्रेडिक्ट कर रहे हैं, they may able to make really good guesses. But even if you are not able to make really good guesses, you can start off with few layers and experiment and move ahead. So make sense? This is where prior knowledge and experience comes in really handy. यहाँ पे अगर साइन का स्क्वायर का फंक्शन होता तो हम साइन स्क्वायर x और यहाँ पे इससे भी सर्कल बन जाता, बट ये साइन का स्क्वायर नहीं, इसलिए इससे नहीं हो पाएगा। Make sense?
यस।
The other thing that I wanted to showcase is मान लेते कि हम मिनिमाइज क्यों करना चाहते हैं, हम ऐसा क्यों ही करना चाहते हैं। मान लेते कि हमें बस ऐसे बस बहुत मन किया, हम तो बस सब में बस मैक्सिमम डालना चाह रहे हैं, हमें आज कुछ तूफानी करना है। सो द क्वेश्चन इज विल दिस वर्क, एंड इफ इट विल वर्क, व्हाट इज स्टॉपिंग अस फ्रॉम डूइंग दिस?
एक्सेसिव कंप्यूटेशन।
मान लेते कि हमारा कंप्यूटेशन पावर भी बहुत ज्यादा है, हमारे पास बहुत पैसा है, हम जेफ बेजोस हैं, तो इन दैट केस व्हाई इज इट दैट वी डोंट डू दिस? ओके, सो उसका रीजन मैं नॉइस डाल के दिखाऊंगा। ठीक है, मान लेते कि मैं नॉइस भी डाल दिया। ठीक है, सो हमारे डेटा सेट में मान लेते हैं कितना नॉइस है, नॉइस थोड़ा हो गया, फुल कर दो, नहीं फुल ज़्यादा हो गया। कितना नॉइस है, इसको मैं इतना बढ़ाना नहीं चाहता अब, चलो ठीक है मैं प्ले दबाता हूँ। ठीक है, So as expected output circle नहीं है. Output circle क्यों नहीं है वो मैं बताऊंगा. ठीक है.
हमारे डेटा के लिए ज्यादा स्पेसिफिक हो जा रहा है.
So what happens is that we started off. Let us say that we are starting off. हमने इससे start off किया and हमारा ये output आया. ठीक है. Then how do we even know कि हमारा data के लिए specific है या नहीं है? The one of the indicators is that हमारा क्या बोलते हैं टेस्ट लॉस एंड ट्रेनिंग लॉस का गैप रिड्यूस नहीं हो रहा. ठीक है. That's one indicator. ठीक है. And the other reason, if you take a look at this, तुम देखोगे यहाँ पे ये न्यूरॉन, ये देखो ये न्यूरॉन से इनका कनेक्शन देखो भाई, इसमें कोई डेटा ही नहीं जा रहा है. तो एसेंशियली मींस दैट यहाँ से इधर भी नहीं, यहाँ से इधर भी नहीं जा रहा है, व्हिच मींस कि ये चार के चार न्यूरॉन कुछ कर नहीं रहे हैं. दैट्स, ये हमको आंख से दिख रहा है, बट व्हाट इफ हमें दिख नहीं रहा है. ठीक है. व्हाट इफ वी डू नॉट नो, जैसे कि इवन इफ यू टेक ये न्यूरॉन का कनेक्शन, दिस इज कंट्रीब्यूटिंग नथिंग. ठीक है. सो वन ऑफ द वेज टू मेक श्योर दैट हम जो मैनुअली, सो वन ऑफ द थिंग इज दैट वी वांट टू रिमूव दिस कनेक्शन फ्रॉम द कंप्यूटेशन, इजंट इट? उसके लिए देयर आर टू famously used regularization methods, which is L1 and L2. L1 stands for मैं नाम भूल गया यार दोनों का, एक लासो है और एक कुछ और है. हाँ बट हाँ ये दोनों रेगुलेशन मेथड्स है. सो इससे होता ये है कि दिस इज अ मैथमेटिक्स टू मेक श्योर दैट ये जो वेट्स हैं उसके करस्पॉन्डिंग आउटपुट को इग्नोर कराने का कॉन्सेप्ट है. ठीक है. We will not get into the mathematics of it, but essentially the way that we are able to manually find out that these neurons are not contributing, this is mathematically. So even if we have got large number of neurons, this regularization will be able to make sure that it is working even in that case. So if I have turned on regularization and I have put a regularization rate and I click on play, this should work better than the previous case, which you can see it's working better. Not perfect, but much better. So what happens is that ये सब neurons देखो इसने पूरा ignore कर दिया है. दिख रहा तुम्हें? ये सब के सब इसने इग्नोर कर दिया, ये सब इग्नोर कर दिया, एंड दिस इज हैपनिंग बिकॉज ऑफ रेगुलराइजेशन. ठीक है. सो ईदर यू कैन डू इट मैनुअली और वी कैन यूज द मैथमेटिक्स फॉर इट, और एल्स यू कैन डू अ कॉम्बिनेशन ऑफ द सेम.
नेगेटिव वेट और पॉजिटिव वेट कुछ इसमें कुछ अलग होता है?
ओके. सो या इट्स अ लिटिल डिफरेंट. द रीजन व्हाई हमने देखा होगा, हमने बोला कि एक्टिवेशन फंक्शन होता है, तो बायोलॉजिकल न्यूरॉन्स आर काइंड ऑफ बाइनरी, either activated or not activated. The reason why these neurons do not have that, they are continuous functions, because these essentially work on the concept of finding minima, finding slope and everything. तो उस केस में the reason why अगर step function type होगा on off वाला, then वो maths will not become continuous, will not become feasible, and hence we have continuous function. Negative weight का क्या meaning होता है? That depends on your use case, how you define the thresholds. So it's possible that तुम्हारा negative weight तुम्हारे example में नहीं हो, if you are using a activation function which does not support negative weight, but हाँ, it could mean anything in your scenario. You could manually adjust it to make it always positive, but हाँ, there is no one strict way to say कि negative weight का क्या मतलब है. It depends from scenario to scenario. Okay, you can play around with this, so you can play around with the different classification model. जैसे कि ये है, बोलो.
Sir, I think I broke the playground.
It's impossible to break the playground. That's what they have told over here.
But if I could just share my screen, I could show you.
बताओ हुआ क्या, बोलो.
Sir, it's just the playground is repeating the same thing. Like it's not stabilizing.
It's not stabilizing. हाँ, you did not break the playground. It is not stabilizing because okay, तुम्हारा मतलब ये move होता रहता ना? Can you tell me
it's repeating the same thing. It's random data, I guess. It's just two neurons, two hidden layers and two neurons each. And I used X1 and X2 data with no regularization.
The reason why that happens is because there is not sufficient data for the equation to convert. So in terms of mathematics, the function that network computer right now is a non-converging equation. It's not converging. तुम्हारा, if I try to recreate, दो hidden है, मतलब यहाँ पे दो है ना?
No, sir. It's written two hidden layers, not three on top.
ये है?
Sir, deduce one more. Yes, sir. This one.
This one? यही data set use कर रहे हो? यहाँ ऊपर में क्या रखे हो?
Regularization is none.
ठीक है.
And no zero rate. Yeah, that's it. And noise is zero also.
Noise is 0. It's possible that what you got and what I'll get is different because of the training data being random. But but essentially what is happening in his case also, if I just make it this much. But I get your point, रुको इससे हो जाएगा वो example मुझे बस recreate करना है ना इससे तो भाई क्या ही बना रहा है but it does happen in some scenarios that the function does not converge. It does not converge when the number of neurons required are not sufficient and it is not able to find a minima, not able to find a boundary. So हम बार-बार train कर रहे हैं, हर बार train कर रहे हैं, so it is trying to find a minima and then आगे बढ़ते तो minima change हो रहा है. So it is not able to find a minima for it to stabilize. So
yeah, basically the graph is like more like up and down at a very high frequency.
Yes. तो जैसे कि you can see an example of that. तो इस केस में देखो इसने ये function output दिया है. मैं same neuron को फिर से train करूंगा, reset करके तो कुछ और देगा. ठीक है. थोड़ा different दिया. So this is also like मैं play stop करके कर रहा हूँ, but it's possible that ये पूरा का पूरा चीज एक ही training में भी तुम्हारा हो सकता है. When there is not sufficient parameters for the function to minimize itself for the example data set.
Yes, my epoch is at like at 18,000 right now.
हाँ अब वो नहीं होगा अब once it is not reducing अब बढ़ा के कुछ नहीं होगा बस computational power ही waste होगा nothing it will not minimize ठीक है तो so in some cases it will not minimize no matter how much you train it with ठीक है cool makes sense I
yes,
will
sir.
just okay you can play around with this you can ये spiral वाला काफी interesting है you can spiral का boundary थोड़ा और non-linear है थोड़ा ज़्यादा non-linear है but yeah play around with it this I just want to showcase this so that you get a brief idea of how neural network works. Play around with it. If you found something interesting, if you kind of impossible to break this playground because everything is happening on your local. Try experiment with it. Maybe you'll find it interesting, and then you'll be inclined more towards machine learning. If anything, you can reach out to me. I'll just showcase you that this is what we had to primarily cover in this today's session. But I will showcase you one more part. Which
actually, I have another doubt. What is exactly happening when it's showing test loss? What is exactly is it showing? Test loss and training loss.
Okay. You remember the cost function? ठीक है?
Yeah,
okay.
yeah.
Forget everything. मैं बता रहा हूँ. Test loss का मतलब ये है कि हमारा data set अगर होगा, ठीक है? यहाँ पे क्या? यहाँ पे मैट्रिक्स बनता है ठीक है कि हाँ बोलते हैं यार हाँ क्या कंडीशन है हमारा कि let us say that the output is supposed to be a cat and it says that it's not a cat and it's also possible कि opposite okay output is not supposed to be cat it says a cat. So false positive हो सकता है false negative होता है true false होता है true negative होता है चार possibilities हैं ठीक है
yes
ये चार में से बस दो ही actual expected है बाकी दो मतलब गलती किया है so it's a measure to know कि कितना false positive and कितना false negative हुआ so test loss means that measure in the test scenario training loss means that measure in the training scenario अगर तुम्हारा बोलो अगर तुम्हारा ट्रेनिंग लॉस बहुत कम है एंड टेस्ट लॉस ज्यादा है इट मींस दैट तुम्हारा न्यूरल नेटवर्क का नंबर ऑफ न्यूरॉन्स या फिर लेयर ज्यादा है एंड इट हैज डन हाइपर पैरामीटराइजेशन तुम्हारा बहुत ज्यादा होगी तो वही जो केस है जिसमें कि नंबर ऑफ न्यूरॉन्स बढ़ा के करेंगे उस केस में ट्रेनिंग लॉस विल बिकम ऑलमोस्ट जीरो बट टेस्ट लॉस विल बी हाई
Oh, so that means it will train easily, but in the test cases, it will be more getting false negatives.
So in terms of engineering and exam, it's like कि बस रट्टा मार लिया है ट्रेनिंग में एंड फिर टेस्ट में काम नहीं कर पा रहा है.
Yes, got it.
So that's why your model should not be specific to a single data set, but more towards the family of expected data set.
Yes, got it.
There's one more that I wanted to show you, which is उसका नाम क्या था? Teachable machines. Not sure. Have any of you used this at any point? This website?
हाँ यूज किया है बट उसका एक्सपोर्ट ऐसे यूज नहीं किया है बस नॉर्मली ऐसे
Basic.
हाँ
So for the folks
वो इमेज वाला यूज किया है
चलो ठीक है. I'll just quickly show you. This is also a nice way to play around. I'll just use my webcam. So as I had told earlier, I suppose I'm audible even when this webcam is on. Ideally, I should be.
हाँ
As I told earlier, the machine learning model is only as good as the examples that you give. ठीक है. So basically मान लेते हैं कि I take two. एक मैंने V दिखाया और दूसरा मैं मान लो मैं ऐसे बैठा हूँ. And then उसके बाद मैंने मॉडल को ट्रेन किया to recognize between these two patterns. Let us see output में क्या होता है. ठीक है. All of this is happening on your local, so this is also an amazing tool from TensorFlow team. So अगर मैं बैठा हूँ तो class 2 दिखा रहा है, अगर मैं V कर रहा हूँ तो दिखा रहा है. So it's working perfect. ठीक है. But if I just retrain it one second, ठीक है. So इसको अगर मैं delete नहीं remove sample करना था, add class करूँगा, webcam में जाऊँगा. So अब मैंने डेटा करेक्ट करने की कोशिश किया है. मान लेते हैं कि मैं इसमें भी सेम जगह आ रहा हूँ. अब इसको मैं ट्रेन करूँगा. So it will try produce almost garbage output क्योंकि the machine learning model is only as good as the data that it gets. ठीक है. So इसमें भी मॉडल ट्रेन हो गया, टेस्ट वगैरह सब कुछ काम किया. आप देखते हैं कि इसका क्या आता है. So if I just do this, तो देखो भाई मतलब उसको पता ही नहीं कहाँ पे क्या हो रहा है. It is fluctuating. This is because it was there was not sufficient examples to train it, and B इसने डेटा पे ट्रेन किया and हाइपर पैरामीटर्स ज्यादा हो गया and टेस्ट लॉस ज्यादा है, ट्रेनिंग लॉस कम. So yeah, so you can play around with this, try to break the model. So this is another great tool to play around with. So yeah, that's about the basics of neural network and everything we had to cover for the day. I will take questions. ये slides में सेम ही चीज है जो मैंने manually cover किया है, which is neural network and limitation जो हमने अभी देखा, which is your data is only as good as the example that you provided with. Thank you all for staying so long and attending the session. If you have questions, I suppose there was someone who was supposed to have a session at 8 o'clock. I have stopped.
Yeah, I was having a competition at 8. Thank you.
Right on. Right. And the post-event workshop survey form to get the certificate is this. I will just quickly open and see the form with the correct link. Yes, so तुमने ये बस फिल करना है यहाँ पे ये beginners track, ये तुम खुद से फिल करना. Then ये crowdsource वाला तुम फिल कर देना अपने हिसाब से, तुम्हारा crowdsource level पे आप जो है उसके हिसाब से. Then my name is Abel Mathew, so that is Abel. And then the remaining fill करना, and then this is the important part, the last one, which is ये मेल एड्रेस, वही मेल एड्रेस लिखना जो तुमने प्री वर्कशॉप में फिल किया था, एंड यहाँ पे वही नाम लिखना है जो सर्टिफिकेट में नाम चाहिए, एंड यस दबा के सबमिट करना. This certificate is generated automatically. It does not come immediately after fill the form. It is reviewed from the Explore ML team and मिल जाता है कुछ दिनों बाद, but it does not come immediately. So just wanted to point that out. Does that make sense? Okay, ये फॉर्म का लिंक चाहिए तुम लोग को, if I'm not wrong, और लिंक तुम लोग ढूंढ लोगे.
If the team can share, then we are okay with it.
You folks were able to fill it using the bit.ly link, na?
Yes, so last time we filled it.
So yes, we'll do that right now. Yeah, link. Create. And then we have copy. But काम कर सकते हैं. Post workshop feedback, yes, काम करता है. So link for folks to fill. Thank you all for joining. If you have got questions, feel free to ask, or if you want me to play some music, you can play music. Or if Ankita has something to say, we can hear that.
I think we can open the floor to questions, and if they don't have questions, we can call this a wrap up for this session.
Amazing. I suppose the silence as no questions.
I have actually a question. The question is, whenever we are using this machine learning model, like we try to train it to identify the boundaries in the previous case. Similarly, it uses to like characterize what the image is, what is there in the image, whether it's a dog, whether it's a phone. It uses a similar kind of technique.
So image recognition is a whole another thing. So if I take an example, if I take an example of ये एग्जांपल लेते हैं ठीक है. So this is a publicly open source database ठीक है. तो ये 28 पिक्सल का इमेज है ठीक है. ये 28 पिक्सल का इमेज है ठीक है. So there are multiple ways to create machine learning models which is good at recognizing handwritten numbers. Okay. So one of the ways in which you can create this is that to मान लोगे कि मेरा first layer will be taking input of each pixel individually. So this will be 28 into 28 which comes out to be 784. तो तुम्हारा हो सकता है फर्स्ट लेयर तुम बोलोगे 784 है. अब सेकंड और थर्ड लेयर में तुम कितना रखोगे, यू कुड से कि नहीं मैं 10 रखूंगा 15 रखूंगा, ये भी नहीं पता. फर्स्ट लेयर में 784 है ये पता है मैं ठीक है, क्योंकि 28 पिक्सल पे 28 पिक्सल है एंड ब्लैक एंड व्हाइट है. एंड लास्ट लेयर में हम चाहते हैं, हमको ये भी पता है कि लास्ट लेयर में हमारा होगा 9, क्योंकि ये बस 9 डिजिट्स के लिए है कि 10 डिजिट्स के लिए मैं श्योर नहीं हूँ. अगर 10 के लिए तो लास्ट लेयर में 10 होगा ठीक है. अब बीच के लेयर में क्या होगा, दैट डिपेंड्स ऑन योर हाइपोथेसिस कि विल द फर्स्ट लेयर the second layer detect the edges, the third layer detect the curves and boundaries. So it's possible that कोई second third layer में 4 रख के कर देगा, कोई 15 रख के कर देगा. All of them will be different cost functions which are able to handle the data set. What is happening internally, the only way to know is that once your model is trained, only then तुम waves देके बता सकते हो कि हाँ ये model actually में कर क्या रहा है.
Okay, got it.
Any other questions that any of you have? We'll probably wait for one more minute. And thank you so much, Abel. It was amazing to have you in both these sessions, both these days. The crowd learned a lot. I hope they learned and enjoyed the whole session. And don't forget to fill in both these forms because they are really important. And I'll make sure I share it again with all of you who have attended it.
Thanks, Ankita. Thanks, everyone. Thank you so much for staying here. If you have any questions, feel free to reach out to Ankita or the club or me directly. So, yeah.
Thank you for the session.
And before we leave, probably I'd request Abel to just drop in his any of his socials that he wants to share with you all so that you can reach out to him or connect to him.
You can use this username on any platform that you feel like you would find. As simple as that.
Got that. Thanks a lot again. Hope you all enjoyed. I'll stop the recording and